Hello everyone, my name is Mohamed. I am a Java developer. This video is a quick presentation of Froporec Java library, a project I've been working on for the past 2 years now. We will start with a brief introduction to Java records, and then we will outline 4 known limitations of using records in your code. The rest of the session will describe how Froporec helps bypass those 4 limitations. The concept of Java records was first introduced in Java 14. They are allowed to define data structures with less code than what you used to see with typical Pojo classes, and are immutable by default. As we started making use of Java records, we quickly realized there were a few limitations, 4 of which we describe here, and which ultimately led to the development of Froporec library. The first limitation is the lack of an automated conversion tool provided by default. Before Java 14, developers will typically use Pojo classes as data carriers. Imagine all the existing legacy applications with hundreds of Pojo classes. If you decide to migrate all of them to records, you will have to manually rewrite them all, and that surely will be time consuming. The second limitation we describe here is shallow immutability. Imagine you have a record class, and one of his members is a reference to a mutable Pojo class or a mutable collection. In the example you see here, we instantiate a new school record object with the respective field's value. And on the next lines, we are able to modify the content of each field value by either accessing the setter methods of the building info class or calling the typical list modification methods we know. Such a possibility is what makes Java records shallowly immutable objects by default. The third limitation is the inability for a record class to extend any Java class. And this is because every record class is implicitly final while already extending the record base class. The fourth limitation is the fact that the Java compiler will not set default values for the fields whose values are not explicitly set by the programmer. That also explains why we don't have default constructor for records, something we used to see with Pojo classes. Now, before we take you through how Froporec helps bypass these limitations, let's do some quick introduction. Froporec open source library is a Java annotation processor in the sense that it provides a set of Java annotations which you can use in your code. During your project's compilation, Froporec will scan your code and detects all annotated elements, and then will generate record classes based on what you annotated. The generated record classes are publicly accessible and can be used anywhere in your project. The project started back in November of 2021, and as we are speaking, the latest release is version 1.4, published in January this year. The required minimum JDK is 17.01. Now, back to the records limitations we described earlier in this presentation. Froporec is mainly used as a conversion tool, allowing you to painlessly turn all your existing Pojo classes into record classes. All you have to do is to add the record annotation provided by Froporec to either your Pojo classes definitions, or fields referring to Pojos, or even to method parameters referring to Pojo classes. During compile time, Froporec will generate for each one of the annotated elements a record class containing the same fields declarations as the original Pojo class. Froporec also generates a one-argument constructor, which takes an instance of the annotated Pojo class as parameter. And this is how Froporec performs the mapping of the data from the Pojo instance to the record instance being created in this constructor. This is basically how Froporec works as a conversion tool. In case you have hundreds of modules in your legacy project, instead of manually rewriting each one of them as a new record class, Froporec can help you save some time. Apart from the record annotation, which should be used only on project classes, Froporec also provides the immutable annotation, which is meant to be used on your existing record classes and help achieve deep immutability. As we mentioned earlier in this presentation, it's possible for a record class to have mutable members, as we can see in this example. When you use the immutable annotation on top of your existing record class, you can tell Froporec to also convert any other classes of your project. Alternatively, you can use the immutable annotation like this and combine it with the use of an additional record annotation which you place here. So with this example, Froporec will generate the immutable school record class, and instead of having a field of building info type like we had here, Froporec generated a field of type building info record, which actually is the record class generated for the building info project class. When it comes to collection members, you don't need to add the record or immutable annotations next to the collection field. Once you use the immutable annotation on top of the enclosing record class, that's enough. While generating the deeply immutable record class, Froporec will automatically detect the collection parent interface, which is here list, and use it as the generated field type. Additionally, when you look inside the generated custom constructor code here, you will see that Froporec also generated a mapping logic where the data from the list is now stored in an unmodifiable list object. With that, if any code attempts to call any modification methods on this list object, a runtime exception will be thrown. So this was basically how you can achieve deep immutability in your existing record classes by using Froporec. When it comes to extending a record class, this is something you simply cannot achieve by default in Java. But Froporec provides the super record annotation, which can allow you to simulate that. When you annotate your existing record class with super record, you are required to provide an array of existing POJO or record classes. Froporec will read the structure of each one of the classes provided in the array, and then it will pull their fields names and types, and will then add all of the fields declaration to the annotated class structure. Here, for example, when you look at the generated student super record, you will see that it contains all fields from the annotated student class. And besides them, we also have the fields from the person class. And this is how you can simulate achieving a Java record extension with Froporec. We will finish with a quick description of Froporec convenient factory methods. Here we have a simple record class containing 5 fields, but then we only know the values for the first 2 fields. When we instantiate a record class in Java, we are always required to initialize all fields. Knowing the values of only some of the fields will then force the programmer to provide default values for the remaining fields. And in case the development team didn't previously agree on which default values to use, we might have situations where one programmer decides to use the null values simply because he sees that all 3 fields are references to objects and not primitives. But then another programmer working with the same class decides to initialize the score fields to 0 because it's a number, and the other field to false because it's a boolean. To avoid such differences, Froporec provides a way to provide standard default values for the fields you don't want to populate. Using the immutable annotation on your existing record class will generate a record class which also contains factory methods. One of them is a static method, taken a map as parameter, and in which you can specify the names of the fields you need to populate along with their corresponding values. All the remaining fields which you leave out of this map will be assigned a default value by Froporec based on their types. And that's it about Froporec and how it helps bypass the known limitations of Java records. You can visit the webpage froporec.org, where you will find a detailed technical documentation along with code samples. You can also access the project source code on GitHub, where you can also report bugs or make improvement suggestions. Thank you for watching. Bye.